Your intentions are pure, you don't lose anyone. People lose you. Imagine a world where software applications can communicate faster and more efficiently, regardless of where they are or what devices they run on. gRPC is a cutting edge technology that allows different computers programs to talk to each other quickly and effectively, even if they are far apart from or running on different devices. It offers a blazing fast communication, works in various environments, and comes with extra feature like checking off errors and ensuring security. Think of a gRPC as a high-speed, reliable highway for data and information between software applications. Hello friends, my name is Sabi, and in today's video we'll discuss about gRPC. In this video we'll discuss about gRPC fundamental and encoding methods of gRPC. And in the upcoming videos we'll discuss about gRPC, use case of gRPC with telemetry fundamental, model-driven telemetry, and how to configure model-driven telemetry in different vendors, and list and describe telemetry collectors. So what is gRPC and where do we use? Let's discuss. gRPC is an open source communication framework built on top of HTTP2. It was originally designed by Google to enable efficient and accurate low latency communication between clients and servers. It has many functions beyond those required in model-driven telemetry. gRPC is a modern open source high performance remote procedure call framework that can run in any environment. It can efficiently connect services in and across data centers with pluggable supports for load balancing, tracing, health checking, and authentication. It is also applicable in last mile of distributed computing to connect devices, mobile applications, browsers to backend services. So many organizations had adopted gRPC as a preferred mechanism to connect a large number of microservices running within and across the data center. gRPC is a popular implementation of RPC. It was rewrite their internal RPC infrastructure that used for years. So what is RPC? A local procedure call in a function call within a process to execute some codes. A remote procedure call enables one machine to invoke some code on another machine as if it is a local function call from a user perspective. So RPC, a client makes a procedure calls to send data packet to the server. When packet arrives at the server, call dispatch routine to perform whatever services is requested. When the dispatch routine returned, the server send back a reply to the client. Then what is gRPC then? gRPC Network Management Interface gNMI is a specific use case for gRPC tailored for network management and telemetry purposes. gNMI builds on top of gRPC to provide a standardized way for network management system to interact with network devices, making it easier to configure and monitor these devices in a consistent and efficient manner. It is particularly well suited for a modern network management and automation in environment where gRPC already been used. It is used to view operational data, control, and generate telemetry streams from a target device to a data collection system. It is used as a single protocol to manage configuration and stream telemetry data from network devices. gRPC client and server can run and talk each other in a variety of environments. For server inside a Google to your own desktop, and can written in any gRPC supported language. So for example, you can easily create a gRPC server in Java with a client in Go, Python or Ruby. In addition to that, the latest Google APIs will have gRPC versions from their interface and letting you easily build Google functions into your application. gRPC is an open source, uses HTTP2 for transport. gRPC built on top of HTTP2 provide high performance foundation to scale. It brings many benefits, multiplexing, stream prioritizations, binary protocol, server push. It allows the multi-streaming of messages over a single long-lived TCP connections. As a result, this allows the gRPC framework to handle many concurrent RPC calls over a small number of TCP connections between a client and a server. As a result, this allows gRPC framework to handle many concurrent gRPC calls over a small number of TCP connections between client and server. One of the main reasons for using gRPC is that gRPC allows you to authenticate and encrypt through TLS. If you are concerned about sending operational data in the clear and or you want to protect your collector with certificate based on authentication, you can enable gRPC with TLS. In addition to secure and efficient transport, gRPC provides bidirectional streaming and connection multiplexing. This means that you can dial in to a router, push down new config, including telemetry subscriptions, and have operational data stream backed, all within a single unified channel and by using the same underlying data model. So when we talk about the encoding of gRPC, so the encoding on serialization translate data into a format that can be transmitted across the network. When the receiver decodes the data, it has a semantically identical copy of original data. This is what we refer to as serialization. So the encoding method provides an efficient and ease of use between the two applications or between the two devices. The core of gRPC ecosystem is the use of protocol buffers as its data interchange format. Protocol buffer is a language agnostic and platform agnostic mechanism. For encoding data structures, gRPC uses protocol buffer to encode and send data over the wire. Also, it supports other encoding format like JSON. Protocol buffer provides several advantages to make it encoding format for a choice of gRPC. gRPC protocol buffer supports strongly typed schema, and the structure of the data over the wire is defined in the proto files. So gRPC is also defined the proto file by specifying the RPC method parameters and return types. Same tooling is used to generate gRPC client and server code from proto files. Developer use these generated classes in the client to make RPC calls and in the server to fulfill the RPC request. So there are two types of GBP encoding options that we have. One is compact GBP and the other one is key value. When we talk about a compact GBP, the key that the router includes in the telemetry packets simply an integer. So for the interface statistics, whatever it sends, the data is shown in an integer format. Whereas in case of key value GBP, the key is sent as a string. It does not require any .proto file decoder for every path. Data sent across the wire is large. The key value GBP, the key is sent as a string, and strings are matched less efficiently on the wire than variants, but they are self-describing. This means that you do not need a .proto file decoder ring for every path. When we talk about the compact GBP, we need a .proto file. The compact GBP must generate a .proto file or the router for every path that you want to stream and upload it to your collector. For example, if you want to stream the interface status, you must generate a .proto file for that. When we talk about the speed with comparison to JSON or when we compare with XML, GBP has 2200 times better serialization performance and it is 3 to 10 times more compact than XML. When we talk about JSON, so it will be 5 times more faster than JSON. So thank you for watching this video, and we will continue telemetry use case using gRPC in our next video and describe and explain some of the use case of proto buffer. Thank you.